Hello everyone. Welcome to Math Chalet. Strategy for proving trigonometric identities. Before we start, let us clarify on the notation for cosecant. Some people use CSC to represent cosecant. Some people use cosec to represent cosecant. In this channel, we use CSC to represent cosecant. If you are accustomed to cosec, just mentally replace all CSC with cosec. Sorry for any inconvenience caused. Part 1. We start with the more complicated side. Let's look at example 1. The left-hand side is more complicated than the right-hand side. We start from the left-hand side. In this video, we will focus on the general strategy for proving trigonometric identities. We will not go into detail for each example. All the examples will be covered in great detail in future videos. Let's look at example 2. The right-hand side is more complicated than the left-hand side. We start from the right-hand side. Most of the time, but not all the time, the left-hand side is the more complicated side. Hence, most of the time, we start from the left-hand side. Part 2. We begin with the end in mind. In our journey in proving trigonometric identities, we must not lose track of our final destination. This is especially true if we have tangent x, cotangent x, secant x or cosecant x on the less complicated side. Our final destination. Let's look at example 3. The left-hand side is more complicated than the right-hand side. We prove from the left-hand side to the right-hand side. We have secant x on the right-hand side. Secant x is equivalent to 1 over cosine x. During the proving process, if we get cosine x in the denominator, we are most likely on the right track. Cosine x in the denominator. 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 Solved. Hence, we begin with the end in mind. Part 3. Next, we change all trigonometry functions to sine x and cosine x. It is easier work with just sine and cosine rather than all 6 trigonometry functions. Let's look at example 4. We change secant x to 1 over cosine x. We work in terms of sine x and cosine x. Solved. Change all trigonometry functions to sine x and cosine x as only a general guideline. It may not be applicable to every question. This is especially true for tangent squared x, cotangent squared x, secant squared x or cosecant squared x. We may use these two formulas. Let's look at example 5. We change 1 plus tangent squared x to secant squared x. We do not change all trigonometry functions to sine x and cosine x. Part 4. If we encounter the situation, a plus or minus b equivalent to c, we can try factorization or common denominator. In other words, if we encounter the sum or difference of two terms equivalent to a single term, we can try factorization or common denominator. Let's look at example 6. Prove tangent squared x minus sine squared x equivalent to tangent squared x sine squared x. A is tangent squared x. B is sine squared x. C is tangent squared x sine squared x. We have a minus b equivalent to c. In other words, we have the difference of two terms equivalent to a single term. We can try factorization or common denominator. Tangent squared x is equivalent to sine squared x over cosine squared x. Since sine squared x are common to both terms, we factorize out the sine squared x. Simplify. Solved. Let's look at example 7. Prove tangent x plus cotangent x equivalent to 1 over sine x cos x. A is tangent x. b is cotangent x. C is 1 over sine x cos x. We have a plus b equivalent to c. In other words, we have the sum of two terms equivalent to a single term. We can try factorization or common denominator. We change tangent x to sine x over cosine x. We change cotangent x to cosine x over sine x. The common denominator for these two fractions is sine x cosine x. Simplify. Solved. Part 5. If we encounter the situation, c, equivalent to, a, plus or minus, b, we can try expansion or split a single fraction into two fractions. In other words, if we encounter one term equivalent to sum or difference of two terms, we can try expansion or split a single fraction into two fractions. This case is the reverse of earlier case. Let us look at example 6 again. If we work from right-hand side to left-hand side, we need to do an expansion instead of factorization. Let us look at example 7 again. If we work from right-hand side to left-hand side, we need to split a single fraction into two fractions instead of common denominator. Part 6. Next, take note of difference of 2 squared. Let recap difference of 2 squared. X squared minus y squared equal to x plus y x minus y. Let look at example 8. We have 1 minus cosine x and 1 plus cosine x. These look like difference of 2 squared. Simplify. Solved. Part 7. Finally, the most popular identity is sine squared x plus cosine squared x equivalent to 1. This identity can be used in 4 forms. Sine squared x plus cosine squared x equivalent to 1. Sine squared x equivalent to 1 minus cosine squared x. Cosine squared x equivalent to 1 minus sine squared x. Last but not least, 1 equivalent to sine squared x plus cosine squared x. Thank you for watching. Please like and subscribe to this channel.